All right, the next investigation that I want to talk about is investigation 17. This is on page 52 of the textbook. And this one is asking us to do the same thing, sort of, that we did in investigation 16. Right? So it wants us to write a number sentence to describe each figure, and then use the same number sentence to find how many dots will be in figures 4, 10, 100, and then just figure n in general. So in order to do this, first of all, we're only focusing on part A for now. We'll do all three of these exercises, but for part A, we want to write a number sentence for figure 1, and then we want to use that same pattern that we came up with in figure 1 to write a number sentence for figure 2. And then we want to use that same pattern to write that number sentence for figure 3. And by the time we've done that, we should have developed enough intuition about this particular pattern that we can write a number sentence for figure 4 without even having to draw the figure. And then if we can do that, we should be able to make the leap of drawing or writing the number sentence for figure 10 and then figure 100. And if we can do those things, then we should be able to write one for figure n. So that's sort of the idea. The idea here is that we want to come up with a formula that describes how many dots are going to be in any particular figure number, right? So we want to come up with a formula for that, and this is sort of like egging you on, right? It's a way to go about figuring out that formula, right? So before I actually show you one way that we could do this, let me just say that oftentimes students are just tempted to count up the number of dots, right? They'll say, well, there are 3 dots in figure 1, 1, 2, 3, 4, 5 dots in figure 2, 1, 2, 3, 4, 5, 6, 7 dots in figure 3. And so they say, oh, so the pattern is 3, 5, 7. And they can guess pretty easily that in figure 4 there are going to be 9 dots, right? Because it goes 3, 5, 7. So 9 is obviously the correct answer for figure 4. But for figure 10, well, then you have to sit there for a while and count up a bunch of odd numbers, right? You have to say figure 1 is 3, and then 5, 7, 9, 11, 13, 15, 17, 19, 21. So in figure 10, you might guess 21 is the number of dots because you're just going based off of that pattern. But then figure 100, whew, you're going to be here all day counting odd numbers, right? And even if you could do that, right? So even if you figure out how many dots are going to be in figure 100 just by counting 3, 5, 7, 9, 11, whatever, that still doesn't help you figure out what figure n is, right? Like how do you figure out how to describe the number of dots in figure n more generally, right? So now some of you may be able to do that just by doing the 3, 5, 7, 9 approach, but I'm going to show you a different way, a more visual way, right? And a more visual way to go about that. So so I copied the figures down on a separate sheet of paper so that I can kind of work this out. So here we go. So we've got figure 1, figure 2, figure 3. I'm going to put figure 4 on here. We won't actually draw the figure. And then we also want to do figure 10, figure 100, and figure n more generally. Okay, let's see what we can come up with. So one way that I can see this growing is I have a 2 here and then 1 there. So I can see this as 2 plus 1. Now if I try to extend that same number sentence or that same kind of pattern, I think what I would do is draw a line through these 3 and then a line through those 2, right? And so then that would be 3 plus 2. And then for the next one, I would draw a line here and then a line there. So I think that's 4 plus 3, right? So it's 4 plus 3. And so I can guess pretty easily what figure 4 is going to be, right? I went 2 for the blue part. I went 2, 3, 4. So the next one's going to be 5. And for the red part, I did 1, 2, 3. So the next one's going to be 4. It's going to be 5 plus 4. Now the trick comes in jumping from figure 4 to figure 10, right? So what I want you to practice doing is don't just count up. Don't say, well, I started at 2, so I went 2, 3, 4, 5. So by the time, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then say that the next one is going to be 11. Try to see the pattern here. And what you should really do is you should relate these numbers back to the figure number. Any number that changes, right? Any number that changes from one figure to the next, you should try to relate it back to the figure number. Okay, so for example, the red numbers are changing, 1, 2, 3, 4. They also match the figure number, right? 1 is the figure number here, 2 is the figure number there, 3 is the figure number there, and 4 is the figure number there. So I know without even having to count it that for figure 10, the red part's going to be a plus 10. Okay, because that's the pattern. For the blue part, this is not the figure number. It's 1 plus the figure number, or it's 2 times the figure number, or something like that. Well, if I think figure number times 2, then I would get 2. But here I would get 4, and that's not what this is. And here I would get 6, and that's not what it is. So if I think figure number plus 1, then I get 2 here. Here I get 2 plus 1 is 3. Here I get 3 plus 1 is 4. 4 plus 1 is 5. So that seems to be working out. So the blue part is the figure number plus 1. Right? So here the figure number is 10. That means my blue part's going to be 11. And now we can generalize that super easily to figure 100, right? Because I know now that the blue part's going to be figure number plus 1. So for figure 100, that's going to be 101. And the red part's just going to be the figure number, so that's going to be 100. Okay, so now the next logical leap is getting to figure n, right? How many dots are there going to be in figure n? Well, the blue part is going to be the figure number plus 1. So that's just n plus 1. And the red part is just going to be the figure number, which is just n. Okay, so that's the number of dots in figure n. And whenever you get to figure n, I want you to simplify this. So I put parentheses around the n plus 1 just to emphasize that that's just supposed to represent one number, right? That's supposed to represent the blue part of the figure. But when you actually go to simplify this, those parentheses aren't doing anything. It's not like you're multiplying this by 3 or something that you have to distribute. So those parentheses are pretty meaningless. We just have n plus 1 plus n, combining our like terms, right? That would be 2n plus 1. Okay, so ignore that 3. It's not supposed to be there. But anyway, so 2n plus 1 dots in the nth figure. And you can verify this, right, by going back to figures 1, 2, and 3, because we drew this, right? We know that there were 3 dots in figure 1, and 5 dots in figure 2, and 7 dots in figure 3, right? Well, if we use this formula, does that actually work out? Well, for figure 1, n equals 1, we would plug in 1 for n. 2 times 1 is 2. 2 plus 1 is 3. If we plug in 2, we get 2 times 2 is 4. 4 plus 1 is 5. If we plug in 3 for n, we get 2 times 3 is 6. 6 plus 1 is 7, right? So this is working, right? This works. So this is really nice, because now if I just sort of spout it off, how many dots are there going to be in figure 57? Well, it's easy, right? You just plug in 57 for n. Okay? So and that's the power of algebra, right? That's what algebra is really good at. It's really a good way of describing patterns. Okay, well, so that was one way to do it. I wonder if we could come up with a different number pattern for this. Let's try. Go ahead and give the video a pause and see if you can come up with one on your own while I draw these figures out. Okay. So let's see. I mean, I could do something similar to what I did earlier and just go across and then up, across and then up, across and then up. I'm going to get the same number patterns that I got before, so that's maybe not very interesting. I could also go diagonally, maybe, like draw a diagonal. Oh, I just thought of a good one though. Okay, I thought of a really good one. You might not like it, I don't know, but anyway, but just to sort of finish that thought that I was on, I could go diagonally and call it 2 plus 1. So it starts off the same way as what I did up here, but then if I go diagonally here, you have 2 plus 3, and then 2 plus 5. So, I don't know if I particularly like that. Maybe we should do it, just to kind of talk about it. So let's do that. So we have 2 and 1. Then we have 2 and 3. And then we have 2 and 5. So my problem with this is that I think if you're going to take this particular approach, you might as well just count up the dots, right? Because look at how the red ones are growing. It's like, so 2 plus 1, 2 plus 3, and then 2 plus 5. I think we can guess pretty easily what figure 4 is going to be, right? The blue part's not changing, it's just 2 every time. The red part is changing, it's increasing by 2 each time, and since the previous one was 5, the next one's going to be 7, right? So 1, 3, 5, 7. So what I don't like about this is that notice that that this is just the same pattern 3, 5, 7 as what we had originally. It's just been offset by 1 now. So we're starting on figure 2 at 3, 5, 7. But you still have to be able to describe, well, what's the growth pattern here between 3, 5, and 7, right? So I don't find that all that useful, to be honest with you. Because if you're going to do that, you might as well have just counted up the dots to begin with. So I don't know. I don't think that approach is a particularly good one. You have to be able to recognize, I guess, you have to be able to recognize that, you know, here this is equal to the figure number. Here this is the figure number plus 1, I guess, but then here this is the figure number plus 2. So I guess you could say figure number plus 0, figure number plus 1, figure number plus 2. So I guess it's figure number plus 1 minus the figure number. Right? 4 plus 3. Well, maybe that's not a bad way to separate it out, except that your picture doesn't match that. If you wanted to call this, okay, so if you wanted to call this 2 plus 1 plus 0, and then you wanted to call this 2 plus 1, and you wanted to call this 2 plus 3 plus 2, right? You notice that the numbers, they do still match, right? 2 plus 4 plus 3, but it doesn't match what you did with the picture. So I guess a better way to kind of show that pattern so a better way to show the pattern would maybe be to say, okay, 2, it's kind of hard with figure 1 though, maybe I'll try it with figure 2. 2 plus 2, sorry, let me do a different color. 2 plus 2 plus 1, something like that. And this one is this one would be 2 plus 3 plus 2, right? This would show it actually that's pretty nice, because that's kind of like a triangle, I guess. So then going back to figure 1, it's like here you have 2 plus plus 1, but then there's no green part in the middle, so you would just call it, it's getting tricky changing colors, but 2 plus 1 plus 0, right? And then here we would have 2, I actually like this one a lot, 2 plus 2 plus 1. This is a really nice way, actually, as it turns out. Here I am patting myself on the back. 2 plus 3 plus 2. Okay, and so then you can guess, right? Figure 4 is going to be, well, the 2 is not changing, right? So figure 4 is going to be 2 plus, the middle number is changing, 1, 2, 3, figure 1, figure 2, figure 3, figure 4, right? And then the green number is changing, but it's not equal to the figure number, it's equal to the figure number minus 1, right? 0 is 1 less than the figure number. Maybe I should write the figure numbers down just to make it a little easier to keep track of. This is figure 1, 2, 3, 4. So if we're going, for the green, we're going figure number minus 1, right? So if the figure number is 4, the green part's going to be 3. Okay? And so then you can guess, like, I know I'm squeezing this in now, but you can guess for figure 10, blue part's going to be 2, as usual. Red part's going to be equal to the figure number. The green part's going to be equal to 1 less than the figure number, right? And then for figure 100, blue part's still going to be 2. Red part's still going to be the figure number. And green part is still going to be the figure number minus 1. So then when you go up to figure n, blue part's still going to be 2. Red part's still going to be the figure number, right, which is n. And green part's still going to be the figure number minus 1, right, n minus 1. If you simplify this, you should get the same answer as what we got for the figure number up here. Let's see. Let's see what we get. Again, I'm only using parentheses here to emphasize that that's just the green part, but in reality, those parentheses aren't doing anything in this case. We've got, so our like terms are n and n, so that makes, we have 2 n's. And then we have a positive 2 plus a negative 1, that makes a positive 1. So 2n plus 1, sure enough, right? Same as what we got the first time we did it. Okay. Well, so I have this brilliant idea of another way that you could do this. And you know, maybe you came up with your own number pattern, and that's fine, as long as the nth one, as long as the nth figure simplifies to 2n plus 1, I think you're in good shape. But let me just give you one more way to do this that I thought of. Okay, so here's what I noticed. When I was trying to do this diagonal thing, and then I looked forward to the next ones, what I was thinking was, this almost looks like a square. It almost looks like a 2 by 2. Okay, but we're just missing a dot. And so then if I go to the next one, well, it's not quite as clear-cut that it's a 3 by 3, because you're not just missing one dot, you're actually missing a whole bunch of dots. How many dots are you missing? Well, you're missing a 4 by 4. And then if you move on to the next figure, anyway, so what I'm going to do is actually draw in what I'm missing. Okay, and maybe I'll put a little arrow on it to kind of indicate that that's not part of the original figure, but just to sort of complete the square, I guess, right? If I'm completing the square on each of these, then what I see is that I've got a 2 by 2. This is a 2 by 2, and then this is a, well, you could call it a 1 by 1, I suppose, right? So I'm going to subtract a 1 by 1. here I've got a 1, 2, 3 by 1, 2, 3, and I'm going to subtract off a 2 by 2. So I've got a 3 by 3 minus a 2 by 2. And here, wouldn't you know it, I've got a 1, 2, 3, 4 by 1, 2, 3, 4. But I'm going to subtract off, you guessed it, 1, 2, 3 by 1, 2, 3. Isn't that interesting? Okay, so then figure 4. We can guess pretty easily, right? So the thing that I'm subtracting off is the figure number times itself each time, right? So I know that I'm going to be subtracting off, in the case of figure 4, I know that I'm going to be subtracting off a 4 by 4. But what am I starting with? So the black stuff, I guess. Well, I have a 2 by 2, and then a 3 by 3, and then a 4 by 4, so for figure 4 it's going to be a 5 by 5. How does that relate to the figure number? Well, 2 is 1 plus 1, right? 3 is 2 plus 1. 4 is 3 plus 1. So I think it's the figure number plus 1, right? Figure number plus 1. That helps me out with figure 10. Because if the first number is, or if the black stuff is figure number plus 1 times itself, then this is going to be, well, 10 plus 1 is 11. So it's going to be 11 times 11. And then I'm going to subtract off the figure number times itself, so minus 10 times 10. And for figure 100, it's going to be 101 times 101 minus 100 times 100. And for figure n, it's going to be figure number plus 1 times figure number plus 1 minus figure number times figure number. Okay, we can simplify that. That takes a little bit more algebra to simplify. So you remember you have to FOIL, right? When you're multiplying a binomial times a binomial, you have to FOIL this thing. So we're going to do the front, or the first, right? N times n is n squared. And then the outside, n times 1 is n. And the inside, 1 times n is n. And then the lasts, right? 1 times 1 is 1. And then we're going to subtract off n times n. Well, n times n is n squared. So then we combine our like terms. N squared cancels with n squared. We have 2n plus 1, same as what we got the previous 2 times, right? On the previous two attempts. So still 2n plus 1 is what we're coming up with. Anyway, so I think that's really interesting. I like that a lot. I think it's pretty cool. Okay. So that's it for that. I'm tempted to maybe stop this video and do the other 2 parts, parts B and C, on Investigation 17 in another video. In fact, I think I'll do that to kind of make this a little bit more bite-sized for you.